Hi, here we are at section 4.7 on counting. I guess everybody knows how to count, so we're done with the section. Just kidding. So suppose you roll two dice. They're going to be regular six-sided dice. 1, 2, 3, 4, 5, 6. How many possible outcomes? So an outcome would be roll a 7. Well, how many ways could you roll a 7? There's 1 and a 6, 2 and a 5, 3 and a 4, 4 and a 3, 5 and a 2, 6 and a 1. Okay, so now we're going to do all the possibilities. How about a 12? Well, for 12, there's only one way, 6 and 6. Since there's six sides on each die, then you could just multiply 6 times 6. There's a grand total of 36. And here's the possibilities. So this is the only way to get a 2. Here are the two ways to get a 3. 1, 2, or 2, 1. These two are different because, for one thing, you could think of one as a green die and a red die. And the green one could come up 1 and the red the 2. Or the green one could be the 2 and the red one could be the 1. So whenever there's a 1, 3, 3, 1, you've got to switch the order. Notice that on this 2, 2, if you switch the order, it's the same. 2, 2. Okay, so when you do that, this is a grand total of 36 possible outcomes. So we could write out all the possibilities if you've got some extra time and extra fun. I'm also going to use this in another example later on, so I wanted to just bring it up right here quickly. Or you could just multiply 6 times 6. All right, here's a similar example. Flip a coin 8 times. Now that would be a lot of possibilities. So it could be heads, 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 tails, 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 tails. There's one possibility out of a whole bunch. How many are possible altogether? So you could multiply 2 times 2 times 2 times 2 because the coin always has two sides, heads and tails. So you could multiply 2 times 2 times 2 times 2 and get 256. Or more quickly, you could just say 2 raised to the 8th, 256. So is that it? Are we done with the section? You just take a number and multiply with itself a bunch of times? Well, consider this. There's 10 kids in a race. How many first, second, third place finishes are there? So when there's 10 kids in a race, and to be nice, we're actually going to randomly choose who's going to be a winner. When you pick a winner and you say, okay, this child is going to be first place. Well, how many children are left to choose from for second? There's only 9. Take that child and say, hey, congratulations, you got second. Now how many are left? Well, 2 have been taken out. There are 8 left. See, that doesn't happen with the coin because it's not like you flip tails and suddenly the tails falls off the coin. There's only one side on the coin. But with this, the 10 kids in the race, the numbers are going to count down. So yes, we do multiply, but they count down. 10, 9, 8. All right, kick that one up a notch. How about there's 10 kids in a race? How many finishes total are there? So now you've got to go from 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and multiply all of those. Or, in case you haven't seen this before, this is called factorial. So factorial is, you would need to put the number in first, and then go right here to math. So I put 10, and then I went right here to math, move over to probability, and it's the exclamation point, number 4. Okay. There are 2 other situations to consider. So far we have you multiplied the number with itself however many times, or you need to count down. All right? What's next? So the next 2 ideas are very closely related, but there's one significant difference. Suppose you have a group size n, and you need to pick out size r subgroup. So you've got 10 people to choose from. You need to choose 3 of them. Then n equals 10, r equals 3. So the n is always bigger, the r smaller. The main difference is, does the order matter? So when you are looking at those 3 people, does the order of the people matter? Well, if the order matters, then you use what's called permutations. And here's the formula for permutations, and it's beautiful, or you can use the calculator. So that's when the order matters. When the order does not matter, so you've got the 3 people, maybe the 3 people are going to help you cut your grass. Maybe they're going to help you with your homework. There's not a first person, a second person, a third person. So then use combinations. And here's the formula. It's just slightly different. The numbers are slightly smaller because you're dividing by this extra r factorial. Before we get on to numerical examples, we just need to have a little practice on when does order matter or not. So just yes or no here. Runners are chosen for a cross-country team. Does the order matter? The answer is no. If it said that they were at a race or something like that, then there would be an order. Next up, 3 club members are chosen to work on a committee. Well, there, the order does not matter. So we would be using combinations. The 3 club members are chosen to serve as president, vice president, and treasurer. With this one, there is an implied order because usually the president is the top position, vice president is second, and treasurer is third, but there is an implied order there. So you can point to one and say, oh, this one is the first one, this one is the second one, this one's the third one. And then how about answers to a true-false test? Does the order you put your answers in matter? That one is definitely a yes. You have to put your answers. Your answer for number 1 has to go first. Your answer for number 2 has to go second. So you can't just randomly write down your answers and say, hey, you didn't understand, I just didn't put them in the right order. You could try it. Anyway, so there are 11 full-time math teachers at Hartnel, and 3 are to be chosen to serve on a hiring committee. So in other words, they're going to sit around a room and read people's applications for a job. So how many 3-person committees are possible? So this does not mean just take 11, divide by 3, because you're dividing the 11 full-time faculty into groups of 3. No, what we're doing is saying, okay, one group could be Mr. Rand, Mr. Butler, and Miss Contreras. Or it could be Mr. Rand, Mr. Butler, Mr. Perkins. Or it could be Mr. Rand, Mr. Butler, and Dr. Locke. So those are all the possibilities that we would have to count. All right. The way to distinguish this section from all other sections is this section on counting is going to have this phrase, how many. So if it says how many, then the next thing you have to think, okay, that's counting. And for counting, the first thing I need to do is decide, does the order matter? So if they're going to be on this hiring committee, sitting in a room reading resumes, does the order matter? The answer, no. And that means we're using combinations. So here it is if you would like to use the formula. Oh, there it is. I was wondering where my calculator was. If you're going to use the calculator, then first of all, you have to put the 11 on the left-hand side. Next, go to Math, and then we're going to be headed to Probability right here. Go over to Probability, and you'll see there's number 2 is permutations, number 3 combinations, and number 4 is the factorial. So we're going to combinations, number 3. And then once you hit that, it'll put it on the home screen. Then just put the 3 and hit enter. Voila. Okay, another example. There's 15 horses in a race. How many win, place, show tickets are there? Pretend there's a comma right here. Or win, place, and show. That's what it should have. Well, win, place, show is another way to say first, second, third. So does the order matter for a horse race? Yes, the order does matter. So we're going to be using permutations. And if you would like, you could do this formula or use your calculator like the last one. You put the 15 in first and then go to Math, Probability, NPR, National Public Radio, Then put the 3, and after you put enter, it'll give you the 2,730.